I'm Stephen Foskett, and this is Tech Field Day. The video you're about to see brings together a panel of a dozen delegates from around the world who focus on enterprise technology to talk and learn about new technology products from companies like DriveScale. If you'd like to learn more about this, you can go to techfieldday.com. And if you like this video, you can see a lot more at youtube.com/techfieldday.
So I'm going to talk about some use cases and some market observations. We've now been in the market about 6 months, but we've been talking to customers really since day one, and like to share some of the things we've learned there. We've completed a number of POCs over the last 6 months, and we have commitments from several of these folks that their next deployment is going to be based on our architecture when they buy their next racks. One of them is going to be quite a large deployment. They have over 2,000 nodes today, and they're doing a massive refresh of their first wave of equipment, which is now about 4 years old. It'll be something on the order of 600 nodes. It's going to get replaced early next year. We have strong BD activity with Dell and Cloudera especially, but followed closely behind with HPE and Hortonworks. Those aren't necessarily paired. I mean, Dell and Hortonworks are together sometimes, and HP and HPE or Cloudera are sometimes tied together. But we're very close with these guys. And we have a terrific pipeline. Let me talk about what this pipeline looks like. As we've gotten into the market, I call it the penguins on the edge of the ice problem. Every startup has it. Who is going to be the first customer? You have a pipeline, but everybody's sort of like, well, are you installed anywhere yet? So we've got our first 2 penguins in the water now, and they're swimming around. They're not getting eaten. So we're going to promote that, and then hopefully the rest of the penguins will dive in. The kind of customer that's going to be a first customer for a company like ourselves I call bleeding edge customers. In our case, a bleeding edge customer is defined by the fact that their whole business revolves around the application that runs on their Hadoop cluster. So the guy who runs the Hadoop cluster usually reports to the CEO because their whole company is built on the analysis done on that data. The kinds of people that are running those kind of companies, they're in medical analytics, they're in risk analysis, and in finance and in insurance, and they're in ad tech. The whole ad tech vertical is a great market for us. Also, marketing and automation companies. You can name a number of them. They have a lot of data they collect, and it's all on Hadoop. These are large clusters, 150 to 2,000 nodes, but they're not necessarily large companies. Their whole company runs on this stuff. I mean, the 2,000 node company obviously is a good-sized company. They're probably going to go public in the next year or so. But some of these other companies, they're just 25, 30 people with a large Hadoop cluster, at the center of their operation. Following the bleeding edge is what I call the leading edge, and these are companies that their Hadoop cluster analytics informs their product. So it helps them price it, or they do 360-degree analysis of their customers and helps them figure out what their customers look like, how to sell to them. So it's not actually their product coming off of Hadoop, but the way they go to market is informed by the analysis they're doing for Hadoop. These are the guys that say, wow, this looks really interesting. Call me back when you have 10 customers. So we'll see those guys next year. So the leading edge customers will be our prospects, middle of next year or so, after we've gotten a number of bleeding edge guys installed. And then following them is sort of the bulk of the early adopters. These are bigger companies that have large Hadoop clusters. They certainly see our value proposition, but they're really not going to move. They're not going to be first movers with a new company like ourselves. The government security agencies, the big automotive companies doing IoT, IoT and home automation, security. The second tier web businesses are in this group. The people like eBay and Apple and Salesforce don't have inside computer companies built into their organization, and they're willing to buy technology from third parties, unlike Google or Facebook or AWS. And then traditional mainstream computer IT organizations, they're just doing Hadoop POCs right now. The mainstream of the market is not using Hadoop yet, so they're not even really on our radar screen. If you look at the Gartner surveys, there's always this large group, 35% of their surveys, people who have no plans for Hadoop. That's mainstream, mainstream IT. So we're really at the bleeding edge of a leading edge technology. So we're really out there on the edge. Characteristics of our first customers, they gather huge amounts of data from a lot of different sources, and then they grind on it and sell the results of that analysis. They have very regular production analysis of their data. It's either daily or sometimes multiple times a day. They have somewhere between 150 and 2,000 nodes. We're not really selling to people that have 25, 30 node cluster. I'll talk more about that in a few minutes. They have typically become compute bound. They bought their 12 core, 12 drive nodes on Hortonworks advice of 1 spindle per core, and they're out of compute power, and they haven't even used up a third of their disks yet. This is very typical, and they're growing 100% per year. As I said, these are small to medium-sized businesses, really built around their data analytics capability. And a couple of them started in the cloud and now have moved on-prem because the cloud is great with intermittent things, but if you've got a regular production run you have to run every day, you basically need dedicated hardware. You can pay for an entire server for 4 months of AWS fees on that same server. So if you really need dedicated hardware, the cloud is not economical at all for this kind of processing. So what we are providing them is the ability to have more cores per spindle very easily and change that. Even if you buy it in exactly the right configuration, when you start, new analytics tools are going to come along, and usually the amount of CPU per spindle required just goes up and up and up. One of the key points is these guys because of that, they want to upgrade their processors regularly. They don't want to throw their drives away. That's where the real economic advantage of separate lifecycle management comes in. Even up front, they have significant capital cost savings, and they can spend this extra money on more nodes, and that's what they want to do. In fact, that's a great proposition to our partnership to Cloudera and Hortonworks, is that if their customers are using our technology, they're going to have more money to spend on more nodes and more licenses from those guys. Let's take a look at what the Hadoop market looks like. This slide, I haven't seen this slide anywhere else. This is a slide that we kind of figured out by talking to customers and the Hadoop distributors. The x-axis is the number of nodes on a cluster, and the y-axis is the total number of nodes hooked up to clusters of these sizes. So you'll see here there's a whole lot of nodes on these small 10 to 25 node Hadoop clusters. These are typically kicking the tires, trying to figure out Hadoop, trying to figure out how to get value out of your data. And then there's a much bigger group of nodes on really large clusters. We think there's about 7,500 of these smaller clusters out there in the world, and only about 1,000 really big production clusters. And you'll see there's kind of a valley here. And what happens is once you've figured out how to get value out of your data, well, you start dumping more and more data into that, and you very rapidly grow across to 250 or so, 300 nodes. That typically happens within about 18 months. And then you have a steady growth from there at 50 to 100% per year in these environments. So we try to intercept people who have just figured out how to get value out of their data. They're growing their cluster. They're bringing it in out of AWS. So we try to intercept people as they're coming, after they've learned how to get value out of their data and they're starting to really grow, and then as they ramp their cluster, and then as they recycle their old installations into new ones is where we play. Does this make sense to people? Okay. So we think there's an innovation vacuum in this space on the data center management side of things. As Tom said, fragile software required robust hardware, high margin hardware. The scale out software has been made robust so you can use cheap, low margin hardware. There's no margin for the system houses in this space. In fact, in the really big installations, the Googles and Facebooks have disintermediated the system houses and they're buying directly from Quanta and Foxconn. Most of the margin has been sucked into Intel in this space. And so the system houses don't really have enough margin to really think about investing in value added in this space. And so the architectural leadership in this space is coming from the hyperscale guys as it slowly leaks out of them as people leave Google or leave Facebook, or as when Google moves on to the next generation, then they'll publish a bunch of papers on what they did in the last generation. That kind of leaks out. But their architectures are really designed for tens of thousands of servers, not necessarily a few hundred servers. So it's not always directly applicable. So we think there really isn't any strong investment in the architecture for these commodity scale-out data centers. And we see that as an opportunity for ourselves to provide data center scale architecture leadership and products. So we started with rack scale disaggregation of storage and servers. With disk storage, we'll be moving to flash, doing the same thing for flash in the near future. We're doing it for Hadoop today, and we'll be expanding that out to the NoSQL offerings, OpenStack, bare metal provisioning. Wherever they're using this robust software, fragile hardware model of scale out, that's where we want to go. Containers are coming. Yarn, we certainly support Yarn today. But we have some ideas on what we can do underneath Mesos and Docker and Kubernetes in the future. Those things are great, but they have a hole in managing the underlying I/O, and we think there's some things we can do there, which we'll be working on next year. Basically, we want to manage the disaggregated data center, as Tom said. So. That's our presentation. We still have 15 minutes on the schedule, so the four of us are certainly open to any questions or comments that you may have.
What's the TAM of the enterprise doing their own big data environments?
Yeah, so we think that there's about 1,000 customers that we can sell to today in the U.S. There's probably another 300 or 400 internationally. So it's still a nascent market. It's certainly big enough for us. But our firm belief is all the new applications that are coming out over the next 15 years are all going to be scale out organized. The same thing that happened with multi-threading. In the late 90s, everybody, as Intel started putting more and more cores instead of raising the frequency, people were forced to go to multi-threaded applications. And today, almost every application can support maybe 8 to 10 threads very nicely. I think this applications started today are going to be built for a scale-out kind of environment. They're not going to be built for the traditional environment. And in 15, 20 years, this scale-out model is going to be the standard platform for 90% of the computing. That's our belief. But it's still right at the beginning.
And also the point, right, is that though that the number that Gene was talking about of 1,000 very large customers, the number of servers these guys have are into hundreds.
Yeah.
Okay. So the total number of licenses, if you will, is quite large.
We actually took a look at what could we do with this technology in a VM world, but a really big hyper-converged project is 30 or 40 servers. That's it. So at our pricing, we wouldn't make any money doing that. We'd have to go to $10,000 a node to make, or $20,000 a node to make any money in that space. Our list price is $2,000 a node. So we're really, our whole economics and as well as the technology is aimed at hundreds of node kind of installations.
What do you think would be a minimum installation?
What would be a minimal?
Yeah.
Well, we certainly can help people get started the right way. If you're putting together a 25 node cluster as an experimental cluster, if you've come off of a space where each server costs $50,000 or $60,000, when you're spending $5,000 a server, putting together 25 servers is like, well, these things are so cheap, but let's just buy 25. And if they're not flexible, I can just buy 10 more. They're so cheap. So people really run into our value proposition when they're starting to grow to 100, 150 nodes. But that doesn't mean that once we become sort of best practices for large clusters, that you shouldn't start with us at 25 nodes too. It's just that in this early going, the small cluster guys don't really run into the problems we solve, and they're not really motivated to deal with an entry company like ourselves at that stage. You have to really be feeling the pain in order to experiment with a startup like us. And once you get to 100 nodes, you're feeling the pain.
And also in those environments, right, the unit of purchase is a rack.
Right.
Okay. And the rack, as I've shown you, is about 28 servers and.
Yeah, so you have to need more than a rack of hardware for this to really make sense.
Yeah.
Well, Gene, you were making the case that it's really not that much of a risk just because of how much technology that's established that you're using in this solution.
Exactly.
That's true. That's true. And the other thing one of the issues is we've got this quote unquote proprietary hardware, and it's not a standard server. And so what we say about that is it's built by Foxconn, the largest external computer manufacturer in the world. It was co-designed by them. It's very, very reliable. But everything we write to a disk, everything that gets written to a disk, could just be hardwired connected to a SAS adapter on a server. So if we went away, you could take that box out and still re-plug everything in, and it would just work just fine without us. So there's no throwing everything away if this startup went away. And really, we're going to be really happy when we don't have to sell hardware anymore. We built this device because there was nothing like it on the market. If you did an adapter with a standard server, you'd have a lot of power, a lot of cost, a lot of rack space taken up. To get 80 gigabits of throughput for, what's the wattage in this box, Satya?
200 watts.
200 watts, it's impossible with standard servers, and they would cost a lot more. But when we get NVMe over Fabric chips on the front end of JBOFs, we're out of the hardware business, and happily out of the hardware business. And we'll just use our software to orchestrate things.